Guys, I hope you all are good and doing well for the preparation of your upcoming CAIs. Guys, today I'm going to put a lesson on the mechanics, one of your components of mass, course code 9709/42. This is paper 4, and we will start from the very basics because it is this lesson is prepared for not for only for the science students like pre-engineering and pre-medical. It will also work for the those who are taking the journal sciences. Okay, let's start the day. First of all, we should know about the definition of the subject, that is mechanics. We can say it is sorry, it is the branch of applied mathematics that deals with number one, we can see the motion, number two, forces, and number three, I can write, and number three here, the factors that produces the factors and the forces that and the factors that and the factor that causes motion. And in this, mechanics, we have to. This is about yes, as per definition, the force causes the motion, then velocity, then acceleration, then we can say displacement, and then we can say the momentum, etc. There are a lot of physical quantities which we have to discuss about this subject, mechanics. So first of all, we have to divide the mechanics into the two types. We can say mechanics, uh, this one, it has been divided into two main branches. That is, one is called static and other one is dynamic. So if you talk about static, let me change the color. Static deals, this branch, it deals, we can say, uh, it deals with particles, or when particles are at rest, in no, not moving, right? While dynamics, this one, it deals when the particles are in motion. It means they are not in rest. particles are in motion. Fine. Here, guys, here this dynamic further has been divided into two major types. One is called kinematics, and here, and other one is called kinetic. So it means the further division of the dynamic has been taken parts into two. Number one is kinematics, and other one is kinetic. Now the kinematics, first one, that it deals, we can say it deals when the particle or objects is in motion without source of force, and this is kind of kinetics, right? And kinematics. So kinetic, now the kinetic deals, it deals when the particles are in motion with source of force. So the main difference here, without source of force, that deals with the kinematics, and with source of forces we can say that deals with the kinetic. Here, guys, we have few assumptions that is very important while taking this course, mechanics. Assumptions, you can write, I'm going to write it here. Number one, it says that in mechanics, whenever all objects of different masses are considered to be particles. In one thing here, all objects, let me change the color, all objects of different masses are considered as particles. One of the assumptions. So during the questions, we will say that all objects, no matter what masses they have, will be considered as a particle. Number 2 point, you need to keep in mind that there will be no air resistance. And the third one, strings, ropes, wires, etc., like these things are always considered to be massless here in mechanics, right? And the fourth one, this last not the least, there will be no extension uh, in wires or strings, etc. Right? And we can write one more. That pulleys will be pulley pulleys. We can say more than, or a pulley will be considered as, if there is one pulley or more than pulleys, then that will be considered as frictionless. Okay, now we will consider, guys, we will consider a few basic definition, that's like distance and displacement. What is the difference for these two terms? Distance and displacement. Difference, you can see the distance is a non-directional quantity. It is a quantity, non-directional physical quantity, we can say. It's better to use this physical, because all measurable quantities are called physical quantities, so it can be measured. While displacement is a directional physical quantity. So you can better understand this. Suppose we have a point A here, and then B, C, and D. B, C, and D. We need to approach from A to B. We have two routes. If we want to come at D, we have two approaches. Once we can go through from A to B, then B to C, then C to D, right? So this total length from here, any A to B, any AB plus BC plus CD, AB, BC, and CD, that is be written as D, distance, right? This is example of distance here. But if you talk about displacement, we can say it's a directional quantity, and it will be the shortest directed distance between 2 points. Then getting A to D, we need to approach it. So I will draw a straight line that joins A with D, and this is called displacement. Got it? So this is a particular direction from A to D, but that needs different direction to be changed. So that is not a directional quantity. From if we move from A to B, B to C, C to D, so that is called total length measured between 2 points is called distance, and displacement is the shortest directed distance between 2 points. Okay. Similarly, guys, if we talk about velocity, velocity, yes, by definition it is the rate of change in displacement. And along with velocity, we have so many types of it. Number one, we can say it is can be called uniform. That means constant velocity. It can be variable velocity. It can be instantaneous velocity, and one more, the average velocity. any sum of all the velocities divided by number of velocities. So we'll get the average velocities. Okay, fine. So as velocity is the rate of change of displacement, so what will be the physical quantity that will be defined as the rate of change in distance? In place of displacement, if I change this underlined word with the distance, then what we'll call that? We will call, yes, yeah, most of you I think get it. That is called speed, right? Yes, guys. No, so speed, that is also, that has the same, the type of types, like here I dictated here this one, constant velocity, like here it will be constant speed. But if you talk about speed, it will be variable speed, it can be instantaneous speed, and as well the average speed, right? But it is defined as the rate of change in distance, right? Here it should be rate of change in distance. So then that is called, the physical quantity is called speed. And one interesting thing, both can be measured with SI unit, yani SI unit, system international unit of speed. Let me write it here. SI units of speed or velocity, that is equal to meter per second, right? Similarly, the SI, this is very important to know about the SI units. So those who are weak in SI unit, they must read the book, the unit 1. That will help you to find the basic units of every physical quantities. So SI unit of distance or displacement, that will be in meters, right? And one more thing, after that I will discuss with you that, but unit I can write it here, SI units of acceleration, that is meter per second square. Okay, now the next term I would like to discuss with you, that is about acceleration. Okay, here it goes, the acceleration. Yeah, okay, fine. Acceleration, the same, it is called, it is defined as rate of change in velocity, because it's also directional quantity and it is rate of change in velocity, and it has the same types as the velocity has. So I can write as, it can be a uniform acceleration, it means constant acceleration. Then it can have a variable, okay, it can have this type of instantaneous, acceleration, and the final one we can say the average acceleration. Okay, guys, so far the definition concept, I think you're getting it. Only one definition I would like to discuss with you, instantaneous. What means instantaneous velocity or instantaneous speed or instantaneous acceleration? That means at a particular instant of time, moment of time. Yani here I'm going to write this definition. Instantaneous velocity is defined as the velocity of a particle at a particular moment of time. At any particular instant, instantaneous moment of time. Instant words come from the moment of time. You can find the velocity if you leading from point A to B, then in between A and B, at any moment, you can find out what velocity you have. That is called instantaneous velocity. I hope it is clear. Yeah, regarding to acceleration, I can write it as a word, a deceleration, deceleration, or I can say this, retardation. That means the negative acceleration. That means negative acceleration. So whenever you see the particles or the object is retarding or decelerating, then acceleration will be taken as negative. The value of the numerical value of the acceleration will be taken as negative in such with such word deceleration or retardation. Like we can say once you are driving a car and if you certainly apply the brakes to when you see the signal over there, you will start applying brakes to slow down the vehicle. So it means you are producing deceleration. It means the acceleration of the car is going to reduce and finally it will be zero when the car will stop. Right? We will make, when we solve the questions, then these definitions will be reflected more. So guys, here you need to keep one thing in mind, that when an object is moving in a straight line, then it keeps two things. It can move with moving with constant acceleration, or it can move with moving with variable acceleration. These two things we have to deal while discussing the motion of a particle in a straight line. So we need to identify if it is moving with the constant acceleration and variable acceleration. There are two units to be covered with these two topics, and two questions are going to be asked every year in the past year paper. One is taken from the constant acceleration and one is taken as a variable acceleration. We'll get the difference of these two one by one. So first of all, I would like to discuss with you the first case, when the motion of a particles in a straight line with a constant acceleration. Right, guys? We are discussing about the first case of motion of body in a straight line that is moving with constant acceleration. This is the from book. If you want to keep carrying the book of your prescribed syllabus, that is chapter number 1 for mechanics book 1. Okay guys, before we start the motion in a straight line with a constant acceleration, few basic things you need to know about, because it total based. For a constant acceleration, we always apply Newton's equations of motion. Motions that are, number one, that is v is equal to u plus at, and Okay, and number two, s is equal to ut plus half at square, or this can also be written as in books is vt minus half at square, and third one, 2as is equal to v square minus u square, and fourth you can write the s is equal to v cross t for the average velocity. So these are the most the commonly used applications while solving the particular question based on the motion of a body in a straight line, right? uh, with a constant acceleration. Here I'm going to write the symbols, what the symbol demonstrate in the equations. Number one, if you talk about u, here u is called the initial velocity, v is called the final velocity, t is as time taken by the particles to move from one place to another place, a is the acceleration, and you can see what left, s is the displacement, or you can say that is the distance, displacement or distance, depends upon the question. Keep in mind the vector quantities can be negative, but displacement, any scalar quantity, cannot be negative. I will write for you displacement distance. So distance can never be measured in with a negative unit, and but displacement can be, because a vector quantity. Yeah. So here we can say this VAV. Yeah, VAV is called average velocity, and it can be written as the sum of the two velocity, yani u plus v by 2, right? We can formulate like this. Okay, uh, here one more thing I would like to share with you, that is you guys, I want to share one thing here, that vector quantities can be negative, but scalar or non-directional quantities like I will write that example laterally, uh, can not be negative. They will Scalar quantity will always be positive. You need to keep one thing clear. And so here for your assistance, for your more concept, scalar, like we can say the distance, speed, time, right? That should be at etc, that should be always considered as positive, so they cannot be measured as negative. While the scalar vector quantity, if you talk about vector quantity, we can say that is displacement, velocity, acceleration, etc, they can be measured as negative, right? But here they cannot be measured as negative. This was the point which will lead us for the solution of upcoming questions. Okay, here let's start. Before no, no no, before we start solving few questions based on this, I would like to discuss with you few tips, few tips of uh, getting data from the statement. Yes, guys, the tips are as under. Number one, if particle, I can say if particle starts from rest, then its initial speed or velocity will always be considered as zero, right? Number two, if the particle stops, then we will take v is equal to 0 is final velocity. V is final velocity as described before, will taken as 0. Number 3, if the particle is passing from a point, or from any point, right, then you will never be taken at 0 at that point, right, because it's in motion, so it has some speed or velocity. Number 4 point, we will use any respective equations equation of motion depends upon the data, depends upon the questions data. So we need to read the question carefully, and we need to apply any one of the Newton's equation of motion which is suitable for that given data, right? So these are the points. One and okay, right, one more point, 5. The last but not the least point, say the 5 point says if a particle is moving with a constant speed or velocity, or velocity, then acceleration will always be 0, right? So these are the points which you need to keep in mind. Now we are proceeding towards the solution of few numerical problems based on this data. Oh, okay, guys, here are two numerical problems. The problem number 1 states a car travels 9 kilometers in 15 minutes at the constant speed. It means at the constant acceleration, constant speed mean because acceleration is the rate of change in speed or velocity, right, in a particular direction. So the A will be 0. Find speed in meter per second. Okay, you are given what is given here. I can write kilometer is the unit of what, distance or displacement, yeah, 9 kilometer, and in 1 kilometer we have 1000 meter, so it becomes 9 times 1000, it becomes 9000 meter. because the answer we need to put in meter per second. That's why I need to change the units. And in time is taken for this travel is 15 minutes. So t is what? 15 minute. And in order to change the minute into second, we are well aware that in 1 minute we have 60 seconds. So 540 seconds become the total time. We have to find the speed. Yeah, speed we need to find. We know this formula in the triangle formula.